Every game needs an environment to be played in. With top-down video games like this one, it's usually a bunch of tiles placed next to each other to form the ground. In industrial dungeons, the ground is generated randomly based on the seed of the world. Each world is given a unique identifier that determines how everything will be laid out. Let's take a look at how it's done. To illustrate how terrains can be generated in Godot, let's start with a fresh scene that has one node 2D. We'll begin by adding one sprite 2D node to it. This will be our noise sprite. And we'll have another sprite to display our terrain that we generate. We go to the first sprite settings and we assign a texture to it. We choose noise texture 2D. We go to the settings of the noise texture. We create new fast noise light. We select noise type to be Perlin. In the 2D view, you can view your noise texture that you have just created. Let's attach a script to Node 2D. We begin by pulling both of these sprites. In order to do that, we need to enable access as unique name on both sprites. Once we have that, we can work on the terrain sprite. We create a new 512 by 512 pixels image that we will be drawing our terrain onto. We fill it with white to see what it looks like. Then we create a new image texture and assign it to our terrain sprite. Then we update the texture with the newly created image. We can now run the scene to see what it looks like. We get a white square that we will use as a canvas to draw our terrain onto. We can attach a camera to center the texture. Next, we will extract the noise texture that we will use to generate our terrain. Next, we will iterate 512 times 512 times to fill out our canvas. Next, we extract the value at position ij from the noise map. Now we need to decide what to do with the value that we got from the noise map. This is the 3D representation of a noise map, where white areas represent values closer to 0.5 and black areas represent values closer to -0.5. We create a function that converts values to colors. For values greater than 0, we choose green, and for values lower than 0, we choose blue. Once we get the corresponding color, we need to put it in our terrain sprite. What we do is we call the setPixel function and put the color at position ij. And finally, we get this terrain where the color blue represents values lower than 0 and green represents values greater than 0. This forms the basis of our terrain generation. Obviously, you can also be more specific with these values. For example, for values lower than -0.3, you could have your water. For values between -0.3 and 0, you could have your sand. For values between 0 and 0.3, you could have your grass. And for example, for values greater than 0.3, you could have your stone. If you want to render your tiles in Godot, ideally you would use something like TileMapLayer, which allows you to draw your tiles more efficiently than if you just render them in separate sprites. But this one generally works best with the 47 tile system, which requires you to draw a lot of tiles. And I think there is a better tool for the job. If you open up Godot and go to the Asset Lib tab, you can search for TileMapDual and it will bring up this add-on that you can install. This is what their GitHub page looks like. You can scroll down to the Introducing TileMapDual section, and it says here that you don't have to create the whole 47 tile set system. You can just get away with 15 tiles, and it will auto-tile your maps beautifully. It works with square, isometric, and hexagonal grids. I will now download this repository and show you something interesting. Now in the repository, if you go to the examples folder and open up the shaders TSN scene, you'll see this grid. The way this works is that they provide a tileable blueprint where the entire surface is colored red. The red color acts as a mask that you are meant to overwrite with your own terrain design. They also include an example terrain, which in this case is 144 by 144 pixels. You can go into a sprite, create a new canvas, draw your own terrain, and then import it into this tool. So let's head over to a sprite now. So in Sprite now I can create my own terrain. Let's say I'll choose this color for my grass. Remember, we need grass and water for our grid. So I'll create maybe like a wave or something like that for my grass. But the question is it going to be tileable? If we go up here, view, and select tiled mode to tiled in both axes, we can see that it's not tiling at all. So we have to draw it again and make sure it tiles nicely. Something like that will do. I'll make another one for our water. Make sure to save it in your projects folder. Also, I would like to make 2 new versions of this atlas here, because as you can see, some of these colors will not fit very well with my design for the water and the grass. Awesome, that's for the water. And this is for the grass. Remember that the red color has to remain red. Okay, back in Godot, I have now imported my assets here, my grass atlas and my grass overlay, and also my water atlas and my water overlay. Remember that this red color will be replaced by this overlay. So what I will do now is remove these 3 components and add new TileMapDual, and also duplicate it to create another layer for our grass. Now, there are 2 things we need to change. The first one is to replace the atlas. The other one is to replace the overlay. So we create a new tile set, go to the tile set tab and import our atlas. We click yes because we want to create tiles in the atlas. Then we apply that shader. We also have to make it unique so that these layers don't interfere with each other. We update the overlay and we do the same for the second TileMapDual layer. So I update the grass overlay. I create a new tile set. I import my atlas. And with this, I should be ready to draw in layers now. So what I will do is go to the tile map, select this square, and start drawing. And as you can see, my overlay is now visible. I can now go to the second layer, select this coordinate, and start drawing around the grass. As you can see, it's tiling very beautifully. I could even try some more intricate shapes, and it's still doing very well with those as well. Obviously, you would repeat that for the stone layer, the sand layer, but you get the idea. And obviously we can use the code that we wrote previously to generate our terrain through code. We pull these 2 TileMapDual nodes using these 2 lines of code. We use noise this time as an exported variable. We iterate a couple of times, get the noise value, and use this setCell method on the TileMapLayer to set a cell. The first parameter is coordinates of the cell to be placed in the TileMapLayer. The second parameter we keep at 0. This is the tile's unique identifier within this tile set. And for atlas coordinates we use 2, 1, which is this tile that we use for drawing. And running this code now produces the following result.